Okay, so a very good morning to all of you. Am I audible? And the slide is visible?
Yes, sir, you audible. Good morning, sir.
Yes, sir.
Yeah. So from day after tomorrow, I mean from 17th, you are having your internal exam. So today is the last class of this particular subject. Tomorrow will not be discussing about this subject. Okay. So whatever will be taught in today's class, this will be your syllabus. Okay. So as per the syllabus, I'll share the materials with you. Okay. And please make all of this these calculation of delay. This is very important. Okay. And these timers, zero timer, I mean timer register, timer control register, and timer mode register. Timer control register will be discussed today. Okay. Okay. So whatever will be in the today's class, this will be the your syllabus. I mean up to today's class. Okay. Okay, so we are starting that we are just recapitulating this. There are four modes available in the 8051 microcontroller: timer mode, timer counter mode. There we can see mode 0, that is 13-bit timer mode, mode 1, 16-bit timer mode, mode 2, that is 8-bit auto reload mode, and mode 3 is the split timer mode. Okay. And we have also discussed that where and when this gate will be one, and C oblique T bar, this counter oblique T bar, timer bar, when this bit will be set. Okay. So the concept of this gate, okay, we'll discuss. At first, see that in the PPT you can see that at first there is an crystal oscillator. Okay, so there is a crystal oscillator, and as we have we can remember that each of the periods can be defined by the crystal oscillator by 12. Okay, so now this part is connected here, and T0 pin of that is pin number 3 I mean port 3.4, that is the fifth pin of the port 3, that is the parallel function that is done by port 3 pin number 5, that is P3.4, is the timer 0 pin. Okay, and this P3.5, if you can remember the pin configuration, then you will remember that this is the T1 pin. Clear? Okay, so we are now coming back here, C oblique T bar. Okay, now whenever this C oblique T bar is 0, that means timer operation. Okay, and C oblique T bar is 1, then counter operation. Now, whenever we are counting some external events, then counting operation, and whenever some timing operation is in the internal event, that is the timer operation. Any external events, counter operation; internal events, timer operation. Is it clear? Clear or not?
Yes, sir.
Okay. Now see that this is acting as a switch. This is a switch. Okay, this is the switch. Okay, so this switch is connected to this C oblique T bar equals to 0. That means what? That means what?
Counter operation is happening.
What? Counter operation is happening.
Sir, timer operation.
C oblique T bar is 0. That means counter is 0. So counter operation कैसे होगा? इसका वैल्यू 1 होगा. वैल्यू 1 होना चाहिए. Then the result will be 0, right? Counter operation will be in this case, this particular case. Okay, okay, forget about that. Whatever be there in the figure, we'll discuss this. Then after that, we'll change this. Now C oblique T bar is 0. So this is connected. So some crystal oscillator frequency will be there. So some some input will be there from this way. Okay, clear? Some input should be there. Now this switch is open. Okay, this switch is open, so here no output will be there. This switch is open. Okay, understood? Okay, now I am removing this one. Okay, so now come to this part. Okay, now in this part, that gate is complemented and fed to an AND gate, sorry, OR gate. Okay, and INT0 pin, that is the pin number 3.2, port 3, third pin, that is P3.2, that is connected with the OR gate. So when will be the output is 1? When will be the output is 1? When either of this is 1, then only. Clear or not?
Yes, sir.
Okay. Now suppose whatever the value is, okay, whatever the value is, our objective is what? Our objective is to turn on this switch to get the output. Our objective is that. Yes or no?
Yes, sir. Yes, sir.
Okay. So this output should be 1. Our objective is like this. Unless this switch will not be closed. When it will be 1, then this switch will be closed. Clear? So when it will be 1? When both are 1. Okay. So here TR0 is nothing but the timer run control bit. Timer run control bit of timer 0. Clear? So in the input of this particular AND gate, that is 1. Both inputs are 1. So here we need 1. So to get here 1, so what will be the content? I mean, what will be the input of this particular input? Now for we are just getting back. Now you can see, just a minute. Yeah, gating control when set. Okay, timer counter is enabled only when INTX pin is high and TRX control pin is set. That means what? INTX is, this is 1 because high is 1, low is 0, and TRX pin is set. Set means 1, reset means 0. So both are 1. Okay, understood or not?
Yes, sir.
So obviously, just a minute, this pin will be set. This will be 1. This INT0 pin. So here will be 1. Understood? And automatically this is, if this is 1, then the output of this particular NOT gate will be 0. So the input of this OR gate will be 0, 1. Clear or not?
Yes, sir. Yes, sir.
So 0, 1. So what will be the output of the OR gate? This is the OR gate.
1.
1.
Okay. So what will be the input of this particular AND gate?
1, 1.
So 1 and 1.
So then the output of the AND gate will be?
1.
So then the switch will be closed.
Yes, sir.
And the output will be there. Okay, so we are removing this cross. So output will be there. Clear or not? Understood clearly?
Yes, sir. Yes, sir.
Okay, so whenever the this particular, whenever this is the timer operation, whatever we have discussed, this is the timer operation. Now whenever this particular switch will be moved to here, will be moved to here, then counter operation will be there, okay, and rest of the things will be unchanged. Okay, that means this gate will be 0, int 0 will be 1, tr 0 will be 1, and the output will be 1, because unless this output of this particular AND gate, is 1, then this switch will not be closed, right or wrong? What happened? Am I audible to all of you?
Yes, sir.
Right, sir.
Yeah. So we are proceeding. Now this is the timer control register. Okay. So whatever has been discussed, the mode selection can be done by using this timer mode control, a timer mode register, and here the timer control register, that is the TCON register. Okay. So this timer control, TCON for timer control. Now you can see in the bit pattern, you have to write this bit pattern in your copy, because you need to write also. Otherwise, this will make a confusion. Okay. So as can you tell me that what are this 1 and 0 has been written? Can you tell me, anyone? Here you can see TF1, TR1, TF0, TR0, I1, IT1, I0, IT0. So 1 and 0s are there after every nomenclature.
This is for
Yes.
timer 1 and timer 0.
Okay. So TR1 will be for which timer?
For timer 1.
Okay.
Timer run control.
Yes. So everyone understood, or any query? Why this is 0 and 1? Because I am repeating, because this 1 means for timer 1 and 0 means for timer 0. Clear? Timer or counter, whatever. Whenever I am telling timer, then you will by default you can think that there is a counter also. Okay. So firstly, this TF1 and TF0. Okay. So as as both of the bits, this TF1 and TF0, both of the bits are same, but they are applicable for two different timers. This TF1 will be applicable for timer 1 and TF0 will be applicable for timer 0. Okay. So we'll see what is this. This timer control overflow flag. Okay. Set by hardware when timer or counter 1 overflows, cleared by the hardware as the processor vectors to the interrupt service routine. Now what is this? Now suppose I'm telling you that you have, if it is a counter operation, suppose this is the counter operation. So I'm telling you that you will have, suppose 10 minutes, you have 10 minutes to submit your assignment. Okay. So what you will do? You will do like you will try to complete your assignment by 9 minutes 30 seconds, and you will keep 30 seconds for uploading and submitting. Okay. So suppose this or anyone can complete the assignment by 7 minutes, and he can complete and submit his or her assignment within 8 minutes. It may be possible. So what we'll do then, afterwards you will tell that, sir, I have submitted, my submission is complete. Okay. So what does it mean? That means whatever work has been assigned to you, you have completed, and you will get you are giving and a confirmation that I have completed my job. Okay, so this is the thing the timer overflow flag does. So this timer overflow flag, whenever a timer or counter operation is going on, then after the end, when the timer or counting operation or timing operation ends, then this flag will be set. Then the user will be able to know, or the programmer will come to know that, okay, this timer has been timer or counter operation has been completed. Clear? Clear or not? What is the function of this timer overflow flag?
Sir, can you please repeat?
Whenever a counter operation or timer operation has been given to or assigned to the 8051 microcontroller, then what is expected from what is expected from the microcontroller? It is expected that after the execution of the task, the microcontroller will let us know that, okay, मेरा हो गया, काम हो गया, खत्म, आपने जो काम दिया था मैंने खत्म कर दिया, इट इज डन. ओके, तो हमको क्या करना होगा? अगर हम बात नहीं कर सकते तो क्या करेंगे? हम कुछ इंफॉर्मेशन देने की कोशिश करेंगे, जैसे कि हाथ उठाएंगे या फिर मतलब हाथ खड़ा करेंगे या खुद खड़ा हो जाएंगे या फिर कुछ आवाज करेंगे, है ना? तो दिस काइंड ऑफ एक्टिविटीज आर डन बाय the 8051 microcontroller by means of overflowing the TF1 or TF0 flag. If timer 1 is completing the job, the assigned job, then TF1 will be set and TF0 will be set when timer 0 will be acting. Understood?
Yes, sir.
Okay. Now this TR1 and TR0. Okay. This is a very interesting thing. Unless and until this particular bit is set, this TR1 and TR0 is set, until the starting of this, I mean set means this will be set to 1. Sorry. This is set to 1. Unless this is set to 1, the timer will not run. Now why? Why? Can anyone tell me?
Because it is the complement of the timer.
Yes, if we go
Because
back.
it is. Yes, sir.
Yeah, because we if we go back, you can see this, unless this TR0 is set, this is 1. This will not be 1, the output will not be 1. Clear? So this must be 1 to get the output, final output, I mean final counter operation. Okay, understood? So here this TR0 and TR0, I mean whenever this is applicable, in case of timer 1, this TR1 bit will be set, and in case of TR0, the timer 0 TR0 will be flag will be set. Okay, clear? Clear or not?
Yes, sir.
Okay, so these 4 has been done. So now we are coming to IE1 and IE0. Okay. Now IE1 and IE0, you can see these two. So IE1 is the external interrupt 1 edge flag. So set by the CPU when the external interrupt edge H to L transition is detected. Now what is H to L? Can you tell me what is H to L?
So high to low.
Very good. That means whenever a square wave is there, so continuously the square wave changes its position from 0 to 1 and 1 to 0, 0 to 1, 1 to 0. So 0 is low and 1 is high. Okay. So whenever this IE, whenever this flag is set and this is detected, when this H to L, that means whenever external interrupt comes in a form of square wave and it falls from high to low condition, then this particular IE1 is set. Okay. And when it is cleared when the interrupt is processed by the user or the programmer. Okay. So processed means what is interrupt? Suppose you are sitting in the class and you are at your home alone and someone knocks at your door. What will do? You will take the phone, keep the copy in the in the table or something, and you will go to check that whether anyone came or not. Okay. And if you think that this is a salesperson, so you will not entertain, so you will get back to your study. Otherwise, if you are opening the door and see that your father or your mother or your brother is standing outside with a with some marketing things, okay, so you will address him or her, and he will he or she will come inside your home. You will put the door locked and you will get back. Okay. So this is the process. So depending on the priority, you are setting your job. Okay. Agar the person is not important to your job, then you will not entertain him or her. Okay. Whenever he is or she is important to your job, then you will process this accordingly. Okay. So this is the processing of the interrupts. So those knocking at the door, that was the interrupt, and processing the interrupt is the processor's choice. Clear? Processor's priority, not choice. This is the priority. Okay. And the last one, that is IT1 and IT0. Okay. So this is also done. So IT1 is the interrupt one type control bit. Okay. This now set or cleared by the software. That means to specify falling edge or low level triggered external interrupt. There, that means this particular bit, only this bit can be, not only because whatever we have seen, that TF1, just a minute. Yeah. So this TF1, TF0, IE1, I0, tier 1, tier 0, IT1, IT0. So I have categorized them as cross one and tick one. So can you tell me what is the criteria? I mean, depending on which criteria I have crossed them or put a tick on them. Can you tell me?
Sir, the tick mark was the control bit, and the cross are some interrupt or flags.
You are reaching, but it is not absolutely correct. You are reaching towards it. Please try again. Try once more. Anyone? Now there is a, I mean, I have categorized them depending on a particular criteria, one criteria, only one criteria, and that is again available in this slide itself.
So the cross are the flags.
No.
The TR1 enables timer 1 and interrupt 1, and TR0 enable timer 0 and interrupt 0.
No, I have not asked this. I have asked that I have put cross, 4 cross are there and 4 ticks are there. So I have categorized those crosses and ticks depending on a particular criteria. So what is the criteria? Now I am giving the underline. Now you will tell.
According to
What is written?
set by hardware.
Okay. And by reading this particular external interrupt, okay. Okay. Understood or not? I've categorized depending on this particular specification, and you can see if we erase those things, you can see this tier 1 is, tier 0 is, IT1 is, and IT0 is. Understood or not, everyone?
Yes.
Yes, sir.
Okay, how the categorization has been done. Okay, so moving forward, now we'll see that what is the timer modes. Okay, that has been discussed in the earlier class, and the operation was doing on the T mod register depending on the timer mode control bits, that is M1 and M0. Okay, so whenever M1 M0 both are 0, that is mode 0, that is the 13-bit timer mode. So you may have a thought that this the timer register is 16-bit register. So why is a 13-bit? Okay, why 13-bit, sir? So let me tell you that.
Some mode 0 here.
Yes, mode 0. So here we can see timer high part will take 8 bits, a timer low part will take 5 bits. So 8 plus 5, that is 13 bits. Now rest of the things are same. You can remember whatever has been discussed, crystal oscillator divided by 12. So a square wave pulse is coming. Okay. So when this particular, each square wave pulse, from here, just a minute. From here to here, okay, 1 count. Okay. From here to here, 2 counts. From here to here, 3 counts, like this. Understood? So whenever these counts will be taken by this timer, whenever this particular bit is set to 1. Clear? And as C oblique T bar is 0, so this is the timer operation. It is hard to understand because by using a mouse I can't write properly. Anyway, so now whenever this bit is set, so this will be giving some output like this. Clear or not? And so on. So up to how much it can count this 13 bit. Now you can see, just look into the copy. Now look into the copy.
FF1F.
Yes, because if we look into the copy, then it is a 8-bit register. Okay. So whatever we have seen, that this, okay. So this is the higher part and this is the lower part of the timer. Okay, lower 8-bit and higher 8-bit. Clear? So in the higher 8-bit, what will be the maximum value? All 1. Okay. And what will be the maximum value in the lower part? Here 5 bits will be used. So this will not be addressed. So by default, they will be 0. Okay. So this will be all 1. So this is F, this is F. And if we take this will be 1, this is F. So what will be the maximum count by 13 bits? That is FF1F. So this timer can be able to count up to FF1F. Okay. So if when this FF1F is completed, when the timer operation is done, then timer overflow control bit of particular timer I mean whatever it is, timer 0 or timer 1, that will be goes high. Clear? Because after the FF1F, this timer will go back to 0. Why? Because it will start counting from again 0, 1, 2, 3 and so on up to FF1F. So this cycle will be continued. Okay. Whenever this is TF goes high, then TF flag is set to 1. Understood or not? Everyone understood or not? Okay. So just like the 13-bit timer mode, we can see this is the 16-bit timer mode. So 16-bit timer mode, obviously there is no confusion that FFF, this is the maximum count, and similarly the next count will be 0 because it will, this is the maximum count, then it will again go back to 0, 0, 0, 0, and it will come, I mean count up to FFFF, and similarly this TF flag will be set. Now just like this. Okay, so I think this will not be a good choice to proceed forward, because you will not be able to complete this in your internal examination. So I am concluding today's class, and I'll share those materials with you. Okay.